So we start lesson 1.1. It's about sequences, series, and sigma notation. It's not a very hard lesson. You just need to know the rules, know the notations, and sure you will get it easier when we will do the more application in the class. We start the definition. What does it mean, sequence? A sequence is a list of number that is written in a defined order, ascending or descending, so it means it's increasing or decreasing, following a specific rule. Each number in the sequence is called a term. So let's see one of the sequences and let's do the first example so you will get what I'm saying. First example, the question is to identify the rule in this sequence. If I look at this sequence 7, 5, 3, 1, what's happening from 7? How I'm getting 5? I'm doing minus 2. From 5, how I'm getting 3? Minus 2. And then I continue minus and can even continue to get more and more terms. All the time, guys, the first term we call it U1 or V1 or sometimes A1 or B1. It's linked with what do we name the sequence. The second sequence, if you look at it, how you got 3 from 1, it's times 3, times 3, times 3. Those specific sequences, I have a name, we'll see it later on in another video. Let's continue. Now, how do we represent a sequence? A sequence is written using the general term UR, or sometimes, guys, also you can see in some books UN, or sometimes you can see VN, or you can see AN, VN. It's not all the time the same letter, or UR, VR, AR, BR. So with R belongs to Z plus. So all the time we start as a first term with R is equal to 1. Just in case they mention that uh, the first term is U0, we will use U0. But in general, we use as the first term is U1. Now, let's see the sequence, for example. UR is equal 3R minus 1 with R belongs to Z plus. So we start. What is the first term? U1. How do you find it? You replace R by 1. 3 times 1, 3 minus 2, 2. U2. 3 times 2, 6 minus 1, 5. You can here continue. It's an infinite sequence because here there is no limit for R. R can be till infinity. If I take the second example here, UR is equal 1 over R squared. They mentioned that R should be less than or equal to 5, and sure, R starts with 1 when it means R is 1, 2, 3, 4, 5. So just I have here 5 terms. It means we call it it's a finite sequence, and we can find the values. It means it's 1 over 1, then 1 over 4, 1 over 9, 1 over 16, and 1 over 25. Now, what does it mean series? A series, it means it's the sum of the sequence. When I add the terms of the sequence, we call it a series. We represent the series by using the sigma notation. This sigma, it means the sum. So when I write sigma like this, it means the sum of the terms. From which term? From R1 till 10. So the smallest term is 1 and the last term is 10. We will do an example to get this idea. So, for example, if I ask you to find the sum of this sequence to R plus 1 from R1 till R5, it means I need to find the sum of U1 plus U2 plus U3 plus U4 plus U5. So I replace R by 1 and I'll find the first term. It will be 3. R by 2, 2 times 2, 4 plus 1, 5. R by 3, 7, 9. And then I add, and then we will find the sum of the sequence is 35. As I said, sometimes R can be 0, but if it's given like this, we will start as the first term is 0. And in this case, you need to be careful. When I say, for example, from R0 till R equal to 5, how many terms I have? I have 6 terms. How do you find the number of terms? You subtract plus 1. It means if I want to find the number of terms, for example, between, let's say, U7 till let's say 17. How many terms that is? I do 17 minus 7 plus 1. So it's 10. So it's 11. So I have 11 terms between U7 and U17. That's why if I start with U0, from U0, for example, till U5, I don't have 5 terms. I have 6 terms because the number of terms is 5 minus 0 plus 1. So I have 6 terms between U0 and U5. Now let's do some application. For each of the following sequences, write the three next terms, then find the general term. So I need to find the general term. I need to find un is equal to what? So if I give you the first example, first I have 2, 6, 12, 20. What I'm doing here to get the second term, what's happening? 2 is what? 1 times 2. 6 is what? 2 times 3. 3 times 4, 4 times 5, 5 times 6, 6 times 7, 7 times 8. And then it goes on, 8 times 9, 9 times 10. But I need to find the relation. If I'm starting with the first term as r is equal to 1, so this is 1. How I'm getting this number 2? It's 1 plus 1, 2. So if I'm starting with 1, 1, then 1 plus 1. Now then 2, 2 plus 1, 3, 3 plus 1. So it means it's r times r plus 1. So if I start with the first term for r1, I will check it. It's 1 times 2. For r2, it's 2 times 3. For r3, it's 3 times 4. So that's it. Let's see the second example. If I look at it, it's 1 over 2, 2 over 3, 3 over 4, 4 over 5. If I will continue, 5 over 6, 6 over 7. So what is the relation? The numerator is all the time r, and the denominator is plus 1 of the numerator. So if I start by r1, so it's 1 over 2. Then if r is 2, it's going to be 2 over 3. So this is the general form of this series sequence. Sure, guys, we will be doing more application in the class. So don't worry, just this is the introduction of the lesson. So hope you got the video, and then see you next time in another video.